Hello everyone, welcome back. Let us continue our training today. Today we will start with understanding what is data warehousing and data lake. Because when you get to, in the case of real-time scenario, most of the time the analytics professionals like us, will be using the data warehouse. Okay, so data warehouse, that is where we store the historical data. As discussed in the last session, it has historical data in it, and also it is integrated with the data whatever we store it here, right? It is an integrated one. For example, your data is available in the source system like sales database, and you have another database for finance, and you have another database for supply chain. We take all those source system database related data and we store it in a common centralized place called data warehouse. Okay, it is an integrate, so it will have an integrated source system data in it, but it will have the historical data in it. Okay, that is what data warehouse. Because if you say you're a Power BI developer, right, you should be knowing what exactly data warehouse is also and what is data lake. Nowadays, most of the enterprises, they started using data lake as well. Okay, and in the case of data warehousing, we use data modeling technique called dimensional modeling. So as part of dimensional modeling, there are two types. Other one is star schema and snowflake schema. Now we will first understand what exactly data warehouse is all about. Though I discussed it already, but still I just want to give you a quick recap on what exactly data warehouse is. For example, look at here. If you look at this block diagram, so you can see it here on the right side. So this is what your data warehouse. Okay. So let's say in your company, they are using CRM application or ERP application, enterprise resource planning, for example, Oracle apps, Oracle applications, and other legacy. Legacy is a very old, applications and other external data. Okay. They pull all the data from these source systems, and then they perform data transformation. They do the data cleaning and data pre-processing, and once they clean and pre-process the data, they load the data into the data warehouse. See, in one of the interviews, my student was asked by, have you performed ETL? First of all, tell me what is ETL. ETL stands for extract, transform, and load. Please remember this. Extract, E stands for extract and T stands for transform and load. So extract, okay, we extract the data from all these source systems. And then what we do is we transform the data. What do you mean by transform the data? We pre-process the data. For example, some files, right, in some cases, some tables, it requires data from multiple files. Okay, so in that kind of situations, for example, you have monthly sales summary table. In that table, you will have to pick up each week sales related data, and then you need to append those things, and then you store it in a single file or single table. Okay, so this is one of the tasks that we perform it as part of data transformation. And also in case of any duplicate records, we need to check if there are any duplicates and our job. Okay, and then it should remove it automatically. So in the real-time scenario, especially in the live environment, everything is automated. We don't go and manually check whether this data file has or this table has duplicate records or so. Okay, so what we do is while we load the data, we make sure that we are not loading the duplicate records in the target table. Okay, so that's the reason why we, as part of the T stands for transformation. As part of the data transformation, we do the deduplication. Deduplication is something like removing the duplicate records. And in case of any missing values, we are going to address, those kind of missing values. Because if you have the missing values in the essential or the important business columns, then it doesn't make any sense if you blindly load it in the data warehouse. So data warehouse is meant for analytics, because here you have the historical data available. So data warehouse is, in simple term, it will have the integrated data from the source system, and it will have a historical data. It is non-volatile. Once you store the historical data, we don't change the data Okay, we don't change the data. Rarely we make changes, but any changes to the data warehouse, like to apply any changes, data changes to the data warehouse, you have to use something like update command. In SQL, we have something like update. And if you want to remove some records, we use some delete command. When you use these two commands, it is cost wise very high because it consumes a lot of memory. And let's say in the case of data warehouse, we store billions and billions of records. If you perform any update against this huge volume of the data, it will literally slow down, or some case it will bring down your system itself. So that's the reason why we don't do any changes to the data which we already stored it. Okay. And the next one is the time variant. It is time variant. Since we store the data on a time based, right? So we can perform time intelligence kind of analysis, like for like analysis, we can do it. So once you store the data, the historical data, which you integrated from various source systems into this data warehouse, this pre-processed data will be consumed by the reporting users. For example, you are using Power BI reporting tool. So in that case, you pick up the data from data warehouse, and then you start to create the reports, and you populate the data into visuals. Okay, so that is what these are the report consumers. Once the data is readily available, which means the pre-processed data is clean data is available, then it can be consumed by the report users. You can report users, okay, or the report developers. They can consume this readily available data, and then they can start create the this one. Okay, the start creating the the dashboards and reports. Okay. So next one is the data lake. So data lake nowadays, right, it is used in almost all the enterprises. It is a centralized repository, like data warehouse. Even the data lake is also a centralized repository. It allows us to store all our structured, unstructured data at any scale. So what are maybe the volume of the data? So you can store as many, or as much data as you can into your data lake. Okay, the data. So the data. So you can store your data assets from your source system. For example, you have an e-commerce system. Amazon is storing all the data in their OLTP environment. So what you do is you can store these data assets into your data lake. Now the question is, why should I have the redundant environment? Already I have OLTP database, and from here I need to push it to data lake, and then from data lake, there are cases will be loading into data warehouse. So why do I need to have to duplicate a redundant environment? So in the case of data lake, based on your reporting requirement, based on your business requirements, the relevant data only you push it here. But the data lake can contain the structured data, unstructured data, and even the semi-structured data. Whereas in the case of data warehouse, it's just structured data. Most of the time we use the structured data only. Structured data. What do you mean by structured data? Let's say the data is stored in tables, right? It's all the data are stored in rows and columns. Since you are storing the data in rows and columns, you can perform SQL like joins, everything you can do it. Whereas in the case of data lake, we can store any type of data, unstructured data. What example for unstructured data is text data. Okay, text data, or you have something called audio and video. These are all the examples for unstructured. You can store any type of images. Okay, GIF file, JPG, or PNG file. It's all type of images, audio, video, including the text file. These are called your unstructured data. This can be stored in your data lake. Okay. Okay, the data. See, so the data is processed after it is loaded into data lake. So whatever the data, this is called your raw data. Sorry, you have the raw data. You store your raw data. Your raw data can be unstructured, okay, or it can be structured, or it can be semi-structured. What is the example for semi-structured? JSON file. Okay, JSON file is not fully a structured one, and also it is not unstructured. It is a semi-structured. Okay, the JSON file. Okay, and structured files or some, something like comma separated value files, right? So those are the structured files. So in the data lake, we store structured, semi-structured, unstructured data. So once the data is stored here, in the case of data lake, as it is from your source system, the source system is, let's say, your OLTP or CRM application, right? So then the data is processed right after it is loaded into data lake. Okay, so the data warehouse uses the ETL, extract, transform, load procedure. The data is transformed and then loaded into the data storage. So in between DL and data warehouse, you have something called ETL. Okay, you have ETL. Okay, so in this case, the data lake is the source for your data warehouse. For the data lake, the source is the OLTP database. Okay, from here, because the OLTP database will not have the historical data in it. It will not know historical data. Which one? The OLTP. The reason why they don't store the historical data in the OLTP database was because the users, right, ordering the products from their website. Say Amazon users, they are hitting the website and then they are keep ordering the products. If they want to see any specific product, they make a search. So in that case, your search should return the values in a much faster way from your OLTP database into your website, right? If it takes a longer time, what will happen? For example, you want to buy Apple iPhone mobile phone, and in that case, you want to see compare the different models of the Apple iPhone with the price and features. So in that case, you need to search it. So the search will, the search will happen behind the scene in your database, OLTP database. If your OLTP database, has billions of records, it will take a lot of time for you to show the different models that are available as part of the Apple iPhone. So end of the day, if it takes more time, obviously the customer will, it can lead to customers dissatisfaction. They will think, this always this website is very slow. Better I'll go to some other website. Okay, so for that reason, what they do is to retain the customers, to enhance the customer's experience. We make sure that the whole TP database, we don't store the historical data. What we do is every once in 6 months or every once in a while, year, the some data, right, part of the data, they will archive it. They will take the backup and then they will remove it from this database so that this database will not have the historical data. Okay, but again, on a case-to-case basis, the data retention strategy will be determined. For example, in the case of banking, you have 25 million customers are there. Okay, so in that case, obviously, whenever the customer want to see their account balance by using their app, they should be able to see the account balance instantly whenever they make any transaction like depositing the money or debiting the money or crediting the money, right? It should happen instantly, right? So in that case also, right, but there are some tables, it will have huge volume of data. Okay, you cannot remove all customers just because your OLTP database should not have historical data. So right, in that case, obviously all the customer details should be there. Okay, so that's why I use the term case to case. On a case to some files, some data, some, let's say, customer data will be available in the database. All the customers data will be available. Okay, hence the volume of the data is very high in the case of customer table, and some tables, right? So what they do is they will archive it. Okay, they, certain things we don't need it. Okay, so for example, the order transaction, we don't need for the last 5 years what are the products ordered by the customers. All we need is which all customers recently they ordered. Okay, so and also what they do is they will track it. So which all orders we need to fulfill it. So in that case, the recent orders, if you related information, if you have it, that is more than sufficient. But to perform analytics, okay, you need to have the historical data. So what we do is every once in 6 months or so, for example, in this case, okay, the order data or invoice transaction data will get pushed to data warehouse. Okay, and then so at any point in time in the OLTP database, you have something called order table. The order table will have only 6 months of data or 6 months of data only. Since you hold, or since you house only the 6 months of data, the volume is not so high. Hence, whenever the user wants to raise an order, it will be pretty faster. So OLP database Now you understood why in the OLTP database we are not storing the historical data, because the performance should be faster. Whenever the user orders, whenever they make any product, it should happen in a pretty fast manner. So whereas when it comes to data warehouse, right, so not all the reports needs to be processed in real time, okay, or near real time. But there are some reports. Obviously, you need to have that reports to be generated in real time or near real time, okay, in order to perform some kind of real time analytics, okay. But not all the reports you need real time or near real time. But now the trend is changing. So you take any department, any managers or any stakeholder, right? So everybody wants the report to be made available in a matter of 1 hour or half an hour. Okay, so they cannot wait any longer than this. So data warehouse is historical data. So again, in the data warehouse, they use different strategies to improve the response time. Here, the query response time is very important, but here concurrency is very much important. Multiple users, they will be accessing the database simultaneously. So in that case, the volume of the data is relatively less compared to data warehouse. But in the data warehouse, you will have huge volume of data. So before loading the data directly into data warehouse from this OLTP database, let's say every once in 6 months, right, or daily basis also, they load the data into data lake. Okay, some structured data or semi-structured, unstructured. It can house any type of file in it. We simply load the data as is. Okay, now the question is, since we are loading it as is, and then we do the ETL. After we do the ETL, we do the data warehouse. So why this layer is coming into picture? Why this layer is coming into picture? So why can't we directly pull the data from the OLTP database and then we do the transformation against the OLTP? No, that is not the right solution, because while pulling the data from your OLTP database, as part of the extraction mechanism, when you do the transformation, right? So for example, for specific file, right, for specific job, you need to join more than one table. Join is an expansion operation, okay? You join the tables, multiple tables, and then you do some kind of, you apply some kind of business logic against this OLTP data. So what will happen is your OLTP database is already overburdened by many users. Already millions of users are accessing it. On top, if you put the burden by transforming the data against this database, it will slow down the performance. So for that reason, what they do is simply take the data and then load it here into data lake, okay, or they say something like a staging environment. Okay, so staging can be a database or it can be your data lake itself. Okay, so they simply load the data as it is. After you load the data here, you do the data transformation, and then what you do is you load the clean the data or pre-process into data warehouse. And once the data gets stored in the proper format or in the required format, this can be consumed by the report users. Okay, so what is the, now that, to summarize, so what is the difference between data warehouse and data lake? So data warehouse, we store it in a relational database, like RDBMS, Microsoft SQL Server. So data lake, we can have it in a SQL or Spark or NoSQL and so on. And, in the case of data warehouse, we write the data, whereas in the case of data lake, we just read the data. Okay, once you store the data as it is, the next step is you read the data from your data lake and then you do the T and L. So you transform the data in the required format. Once the data is transformed in the required format, you load the data into data warehouse. Hence, the data lake is, schema is meant for read only. Data warehouse is meant for read and write only. Okay, and the data format is, in the case of data warehouse, it is structured one. Here, all the type of data is possible: structured, semi-structured, all the things. Okay, and what are the applications that can access the data warehouse? The business intelligence and enterprise reporting related applications can access the data warehouse. Whereas in the case of data lake, I just show you the difference. Yeah, in the case of data lake, look here, the data science You can use, the data scientist can go and access the data from the data lake, the semi-structured, unstructured data, and the machine learning algorithms and streaming processing, predictive analytics, advanced analytics. For all these applications, okay, will hit this data lake to pick up the data from here. Okay. Okay, now we understood what exactly data warehouse and what is a data lake. Data lake is something like a temporary place, right? We just store the store system data into the data lake, and then using the data lake, what we do is we apply the transformation, everything against the data lake. Instead of the source system, we apply the data transformation against the data lake, and then we pull the data and then load it into data warehouse system. Okay, but data warehouse is historical, but data lakes also, right? They depends on the company, depends on the requirement, they determine how much data they need to keep it, right? So there is something called retention period. So the same thing is applicable for all type of database. Okay, so the retention period is common for data warehouse, data lake, and OLTP. Okay, the source system database. Okay, they'll determine how many months or how many years of data should be there in each environment. But when it comes to data warehouse, the volume of the data, the historical data is very high. Probably 5 years of data, or some cases 7 years or 8 years data. Banking and all, they will keep more years of data, because the same customer, let's say a customer has opened their account almost 10 years back, still is information should be there here, right? Because of banking, the volume of data is very, very high. So in the case of OLTP, some cases were just 6 months only they will have it. And in the case of data lake, so whatever the, every 6 month, right? Uh, what we do is some cases, right? We load the data on a daily basis here, some data weekly basis, some data we load it on a monthly basis in the data lake. And the daily data, whatever you load it in data lake, even for that, we do the data transformation and then we load it into data warehouse. There are different types of data extraction mechanism. Okay, so weekly, daily, weekly, monthly, and likewise, right? So they will extract the data. So especially the huge volume of the data in the source system, right? They will extract the data on a daily basis, so that you're not going to accumulate it. For example, if you don't extract the data on a daily basis, and if you extract it every once in a month, what will happen is per day itself, let's say 1 billion record is there. So at the end of the month, right? Every month beginning, 30 billion records you have to load it. So to loading the 30 billion records into your data warehouse, it will take a lot of time. That's the reason why what they do is the daily. So there are some files, right? They need daily, they'll extract on a daily basis, weekly basis, and monthly basis. Okay. So now you understood the clear distinction. The data warehouse is meant for storing the historical data. Whereas data lakes, we don't store the historical data, but we store the data as it is from our source system, OLTP system. Okay, and then the images and audio, video if required, because in the case of artificial intelligence, they use audio, video, and text also, right? So they do it here. They use it here for that purpose, and also the structured data also stored here. Okay, and in the case of data warehouse, we take this structured, semi-structured data, and then we process it and we reformat it and we store it in the data warehouse. Okay, this is just a temporary storage, whereas this is the long-term basis. Okay, we store historical data here. You just think that way. Okay, so when it comes to data warehouse, to model the data, we use a technique called dimensional modeling. Okay, we have something called dimensional modeling. So in case of dimensional modeling, we denormalize the data as opposed to operational systems. Don't worry about this term denormalization. Okay. So for example, this is the thing. These are the three tables out there. You have product, you have a separate table for product, and you have a separate table for subcategory, you have a separate table for dim category. Why you need to have three different tables? Combine these three tables and use a single table. The product table itself will have the information of the category and subcategory in it. Hence, you don't need three different tables. So in that case, you can have only one. This is kind of a denormalization. So as part of dimensional modeling, dimensional dimensional data modeling. Where we do dimensional data modeling in the case of data warehousing. So as part of dimensional data modeling, what we do is we use something called star schema modeling, and then we have something else called snowflake schema. Okay, we can. There are two types of dimensional data modeling. You can design it. One is star schema, other one is snowflake schema. The idea of the star schema is to keep all your numeric values in a separate table. All numeric values in a separate table called your fact table, and put all descriptive information into other tables called dimension tables. So what do you mean by descriptive information? The product ID, product key, and the product name, the cost price, and active start and end date. So these are the descriptive information. But when it comes to the fact table, what we store is product key. Product key. So this is the primary key here. Okay, the product key. But here we don't store the product name. Instead, the product name is available. So what we do is, if you want the product name, we join these two tables based on the common key column product key, and then we will pick up the product name. Okay, product name and the cost price and so on. Okay, so we will do a lookup on this dimension product table, for the product key, and then we'll get the product name. So the product name, we don't store it. Similarly, category key. And then, for example, you have employee key. Okay, so in the case of fact table, we will store the key from all the surrounding dimension tables. In addition to that, we store the facts. What is a fact? For example, sales and the units sold. Okay, sales, this is a quantitative variable, this is a quantitative variable. And we say something like net margin percentage. Okay, these are all called fact. That's the reason why they say fact table in star schema and flow schema when it comes to dimensional data modeling, because the fact table will hold the fact. What do you mean by the fact? The numerical variables. Okay, fine. The sales is a numeric variable or quantitative variable. Units also quantitative variable. Net margin is also the quantitative variable. But we have something net margin percentage. Okay, so they call it as additive features. Okay, this is okay, semi-additive facts. Semi-additive facts or measures. They say measures. Okay, the fact is also called as a measures. So sales is a measure, unit sold is a measure, net margin is a measure, but sales is fully additive measure. Unit sold is a fully additive measure, whereas this is called the semi-additive measure because it's a percentage, right? So you cannot add the percentages. Okay, if you add, it will not. It doesn't give any proper meaning, right? So proper context. Okay, the fact table will have the combination of all your dimension tables keys, plus it will hold the information about the measures or the fact in it. So now, right, so by joining the sales fact table with the dimension tables, you can get the context about each instance of the day, each instance of the records in your fact table. For example, product key is there, and let's say you have dim customer. Let's say you have another dimension called dim customer. Okay, or their dimensional customer, even this one. So the customer table will have only the customer information. Okay, this is something like sales, right? So which customer, for example, in this case, you have something like customer key. So this customer key is there. And here also have the customer key. Since the common column between these two are customer key, we created the relationship with customer key. And then in the dimension customer table, you have the customer name available here. So if you wanted to know which customer purchased which product under which category, and which employee, or which salesperson contacted this salesperson in order to sell this product, how much we sold, how many units we sold, how much of revenue that we made, sales we made it for this customer. you want to find out any specific customer, any specific instance, right? You need to say, or if you want to get the descriptive, for example, if I say customer key is 1000 and the product key is P001 and category key is C001. So in this product key, so we sold this much. Will you be able to understand? No, you'll not be able to understand. So in order to provide context to these measures, we store the descriptive information in this dimension table. Even the dimension table will have the combination of the primary key and then the descriptive information. For example, product key is the primary key. This is called your primary key. What is primary key? Using the primary key only, we can uniquely identify the records. Each dimension table will have unique record for each instance. For example, in this case, for each product, you will have only one record. You will not have the duplicate. So that is what primary key column tells. Okay. So the primary key column, for this table is product key. Okay. And then for this table, category key, employee key, and your customer key, something like that. So, but, the dimension table will not only store the primary key, along with it, we store the product name. With the help of the product name, customer name, employee name, category name, we can add context to your measures. If I say the sales is 1000 and the unit sold is 1200, the net margin is 5%. If I tell you only this one, will you be able to understand? You will ask, is this a total sales or total unit sold? Okay, if I want to know the breakdown, can you give me a breakdown? Okay, the customer key is C001. If I say C001, if I tell you the key along with the sales, will you be able to understand? No. To give the complete context about your measures, you need to join this table with the surrounding dimension tables, because the surrounding dimension tables hold the descriptive information. For example, customer key, Rajesh or John, Michael, so he ordered so and so product. In order to know the product name, you need to join this table with this one. Since the the fact table, since the fact table is surrounded by dimension tables, it looks like a star. Hence, we call it star schema. The fact tables are surrounded by dimensions. Why? So these dimension table are helpful in terms of explaining those facts or the measures. Okay, when you look at any star schema or snowflake schema, so data model, right? So the fact table, you will find it in the middle, and then it will be surrounded by dimension. So it looks like a star, right? That's the reason we call it a star schema. Okay, and the next type of the dimensional modeling is snowflake schema. This is pretty simple, right? So next one is the snowflake schema. It is an extension of the star schema. Okay, and here we add additional dimensions. Okay, so usually representing hierarchies. Instead of just having only one dimension table which captures subcategory, category, everything in it, what we do is we are going to split this table into three different tables, or we are going to decompose this single table into three different tables, so that what will happen is, in this case, we don't store the data redundantly. See, let's say you have in the product table in your company, you sell 1 billion products. Let's say, you sell, the Lux soap, okay, and then you sell Colgate toothbrush, Colgate brush, and Colgate paste. Okay, along with this, if you specify, right, the category here, toiletry item, toiletry, this is a category. This is my category. And this is my product name. And for each and every toiletry item, right, product use, if you put the category column in the product table itself, you need to specify the category name here. Toiletry items, toiletry items. This is redundant, isn't it? This is redundant. Instead of storing redundantly here, you store the toiletry item only one time. Only one time in this one. For this, let's the category C002 or something, category key. Along with that, we specify the category name. So only one record will be there in the dim category. Instead of toiletry item, what we do is we will replace it with C002. See how much space we are saving, right? Toiletry item, instead of that, C002, just 4 digits you are storing it here, right? So that is the thing we do it. So in the case of product table, also you will have the category key, okay, or the subcategory key. The subcategory and subcategory of these two tables will be linked. Okay, based on these two columns, these two tables will get linked. And the subcategory will have the category key and subcategory name here. To get to know which subcategory belong to which category, you need to join these two tables. See, the basically the product dimension table in a star schema, right? In the star schema, this is the one gets splitted into three tables representing the three levels of the hierarchy: the product subcategory, and then category. Okay, in the case of Snowflake schema. So here we are dividing the single table into multiple tables. Okay, more than one table. Right, summarizing by product data for sales would require joining the tables, joining the sales fact table to each level of the product hierarchy until the highest level required for the summarization is required. You need to remember this. If somebody is asking you, hey, can you tell me category wise how much we sales we made? I want to know the sales breakdown by category. So in that case, the dimensional category table is not directly linked with sales fact table. So in that case, right, you need to navigate, you need to navigate to if you want to get the category information, you need to navigate from product table to subcategory, and then only you can get the information in the category table. But the main advantage is you're not going to store the value redundantly. Hence, the main benefit of this one is it uses smaller disk space. It is easier to implement a dimension added to the schema due to multiple tables. Query performance is reduced. Okay. Right. So in this case, since we store the values in a very optimal way, right? So look, for each category, you have only one record, and for each subcategory, we will have only one record. That subcategory, along with that, we specify the category key also. Okay. But here you will not have the category name here. Because the category names are, let's say, let's assume it's a very big one. Instead, we replace the category name by category key in the subcategory. Hence, C002, C003, something if you say, it will not consume much space. So in that case, even if you join these three tables, it will not take much time, right? It will not, the query performance will not get affected. And also it will, consume less space. But in reality, when you join multiple tables, obviously it will slow down the performance, query performance. So that is the reason why even Microsoft recommends use only star schema. Okay. Okay, fine. Okay. So in this case, you don't have to join multiple tables. For example, if you wanted to know the sales breakdown by category, by subcategory, by product, all these information are available here. Hence, you don't have to join multiple tables to get to know the category by sales or category subcategory by sales. If you want to say it, you don't have to join multiple tables. But the only advantage with Snowflake schemas, it consumes less space. Okay, the disk space is very small. Though the disk space is small, but nowadays, if you look at any enterprises, everybody is using Hadoop, the big data system, and hence they are using, the resources with high capacity resources. They use a lot of storages. Okay, hard disk, and they are using a lot of huge CPU, lot of memory, and the CPU they are using it on cloud. Okay, hence since the cost of the hardware came down, now there is a trade-off. Okay, we don't worry about the storage space and all. Even if this storage space takes a little more, let it be there. But end of the day, the response time should be faster. If you wanted to see the report within 30 minutes, yes, we should be able to see the report in a matter of 30 minutes. And if it takes longer time, you're gone. If you join multiple tables, the chances are high that your report data will take longer. So the data in your report will take longer time to get populated. Okay. So now you understood what is the difference between star schema and snowflake schema. So in the case of snowflake schema, the dimension tables, we can find some kind of hierarchy because we decompose a single dimension to more than one dimension. Logically, we do it. Okay, blindly we don't do it. Okay, since in this product table, the product table is candidate for undergoing the decomposition. We are doing it. Okay, don't ask me same way can I do it for store. You don't have, because here you don't have the hierarchy here. Okay, there is no need to split this table. So this table is candidate for normalization. This is called normalization. Normalization is splitting a single table into more than one table. So again, normalization follows some rule. Blindly, you cannot put the values in these three columns. There is a rule called normalization technique. Okay, so using this technique, we split this table into three different tables in this case. Okay, but when it comes to SAS schema, you don't have to do any normalization. It is a completely denormalized one. Denormalized in the sense, combine all the things in a single table in this case. So the star schema is nothing but the dimensional data modeling. Even Snowflake's also dimensional data modeling. But in the star schema, we are denormalizing the tables. We are not normalizing it like how we do it in Snowflake schema. Hope you understood very clearly the difference between star schema and Snowflake schema.